morning, everyone. My name is Rahila, and my topic is about goals, principle, and domain of protection in an operating system. So, let us see what are the goals, principles, and domain of the protection in an operating system. So, introduction. Protection is an essential aspect of an operating system which ensures the safety and security of the system resources and data. Protection in an operating system is like a security guard in your computer. So it ensures that only authorized people or programs can access or modify your important files. It provides a way to control access to resources and ensure that unauthorized access is prevented. Like by controlling who can do what on the system, it prevents unauthorized access or misuse, keeping your data safe from any harm. So there are two components of protection in an operating system. First one is association and another one is authentication. Let us see one by one. So the first one is association. Association is a mapping of a subject to the domain of protection. In other words, it is relationship between subject and the set of resource that is authorized to access. In an operating system, association can be defined as a process of assigning a subject to domain of protection based on its authentication credentials. Authentication credentials can be a password, digital certificate, or a biometric identifier. This means that association is in an operating system. It is like creating a link between a user and the resources they are allowed to access. It's a way of deciding which files, programs, or the data the user can see based on their identity. So the identity is confirmed through authentication credentials such as passwords, fingerprints, or digital certificates. Once the user is authenticated, the system set up the association to determine what actions they are performing on the system's resource. So the next one is authentication. Authentication is a process of verifying the identity of subject before granting access to protected resources. It is an essential component of protection because it ensures that only authorized subject can access protected resources. In an operating system, authentication can be implemented using various methods such as passwords, digital certificates, smart cards, and biometric identifiers. So, authentication in an operating system, it is like checking someone's ID before letting them into the security area. It verifies that the person trying to access the protected resource is who they claim to be. This process is crucial for security because it ensures that only authorized users can access important files. So, common ways to authenticate is by creating a passwords or digital certificates or some smart cards and biometric identifiers. Biometric identifiers in the sense unique physical traits like fingerprints or facial recognition. So next one is, what is the need of protection in OS? To ensure data safety, process and program safety against illegal user access or even program access, we need protection. So, protection ensures that only authorized users or programmers can access the specific files, programs, or resources, following the system's rules and policies. In order to make safe of our resources, we have to ensure data safety. The second point is, it is to ensure that program, resources, and data are accessed only according to the system's policies. As I said, it is only used to save our programs, resources from unauthorized people. It is also to ensure there are no access rights breach, no unauthorized access to the existing data, no virus or worms. Protection helps to avoid security threats like viruses and worms from damaging the system. The virus and worms may cause the damage to the system. So, stealing the data, it also steals the data or causing the systems to malfunction. So we need protection in OS. The last point says there can be security threats such as unauthorized reading, writing, modification, or preventing the system to work properly for authorized user themselves. It prevents unauthorized reading, writing, or tampering with the data, ensures that the system runs smoothly for legitimate users. So the next slide is about goals of protection. So what's the goals of protection? Protection is a method of safeguarding data and processes against malicious and intentional intrusion. For that purpose, we have protection policies that are either designed by the system itself or specified by the management itself and are imposed by the programmers individually to protect their program with extra safety. It means that protection in an operating system acts like a shield to keep the data and process safe from malicious attacks or unintentional harms. To achieve this, the protection policies are established. Okay, so the policies are it may be built into OS by its developers to ensure overall security. Okay, because they will be managed by themselves. Then the programmer impose set by individual developers to add extra protection to their programs. So it also gives a multi-programming OS the sense of safety that is required by its user to share common spaces like files or directories. In multi-programming OS, where multiple users or programmers share resources like files or directories, protection ensures that these resources are safely shared without compromising security. The policies bind how the process are to access the resource present in the computer system. Resource like CPU, memory, software, and even the OS. Both the OS designer and application programmer are responsible for this. However, these policies always change from time to time. Protection policies control how process accesses resources such as the CPU, memory, and software. Both the OS designers and application programmers have a role in setting and maintaining these policies. So these policies evolve over time to adapt to new security threats. So the next slides will be the principles of protection. The first point says that the time-tested guiding principle for protection is the principle of least privilege. It dictates the program's users and even system be given just enough privilege to perform their task. Okay. Principle of least privilege is a key concept in the system protection. Okay, it ensures the users, programs, or systems are granted only the minimum level to access the necessary to complete their task. Okay, by limiting access rights, the risk of misuse or damage is reduced. So the next point is consider the analogy of security guard with the passkey. If this key allows the guard into just public areas that she guards, then misuse of the key will result in minimal damage. If, however, the passkey allows access to all the areas, then damage from its being lost, stolen, misused, copied, or otherwise compromised will be much greater. Imagine a security guard who has a passkey, okay, that opens the public areas she is responsible for. If that passkey is lost or stolen, the damage is minimal because it only provides access to those specific areas. However, if the guard's passkey opens every area in the building, losing or misusing the key could lead to significant damage or security breaches. The next one is domain of protection. Let us see what's the domain of protection. The protection policies limit the access of each process with respect to their resource handling. A process is bound to use only those resources which is required to complete its task in the time limit that it requires, also the mode is which it is required. That is the protected domain of a process. So, protection policy in an operating system restrict how each process access resources. These policies ensures that a process can only use the resources when it is only necessary to complete its task. So, within a specific frame and a mode, okay. This defines the protected domain of the process, which serves like security boundary. Next, a computer system has process and objects which are treated as abstract data types, and these objects have operations specific to them. A domain element is described as object, set of flower bracket open, set of operations on object, close, then the tag. So the processes and objects like files, memory, or devices are treated as abstract data types. Each object has specific operation that can be performed on it, like reading or writing a file, and the domain is defined as those lines. The next point is each domain consists of a set of objects and the operation that can be performed on them. A domain can consist of either only process or procedure or a user. Then, if a domain corresponds to the procedure, then changing domain would mean changing procedure ID. Objects may share a common operations or two, then the domains overlap. In the protection system, the domain defines a set of objects like files, devices, or the memories. So, and the specific operations like read, write, or execute, these are the operations such we have that can be performed on them. Each domain can represent a process, procedure, and or even a user. If the domain is tied to a procedure, switching the domain would mean changing the procedure's ID, as each domain is uniquely identified by the process or procedure operating within it. Overlapping domains occur when two or more domains share common objects or operations. For example, like two procedures might both have the permission to read the same file, causing their domains to overlap. Okay, or else two procedures have the permissions to read the same file, to write the same file. So then the domains are overlapping in terms of access to that particular resources. Like you can see here the domain of protection: execute, read, write, read. See, these two have read operations. This may be overlap. Okay.
Hello everyone, my name is Varsha and my topic is mass storage structure, and disk attachment. So, hard disks are the main form of secondary storage in the modern computers, providing the bulk of storage capacity. Each disk platters have flat and circular shape similar to CDs. The two surfaces of each platters are coated with magnetic material, and the information is stored on the platters by recording magnetically. The magnetic coating allows data to be written and reads from the disk surface. Hard disks are the crucial components of computer system, enabling large amount of secondary storage. The read-write head is a crucial component that flies just above the surface of the disk platter, allowing it to access data. The disk surface is divided into circular track and sector, which are accessed by the disk arms as it moves to different positions. Disk speed has two key components: the transfer rate at which data flows between the drive and computer, and the positioning time, which includes seek time to move the arms and rotational latency to wait for the desired sector. Understanding these mechanical aspects of disk drive is important for optimizing storage performance and reliability. SSDs. SSDs are a type of storage technology that offers various advantages over traditional HDDs. These advantages include greater reliability, faster performance, and low power consumptions. However, SSDs also have some downsides. They are more expensive, offers less storage capacity, and have finite lifespan. Despite these trade-offs, SSDs are becoming increasingly popular in applications that prioritizes program performance and efficiency, such as storage arrays, laptops, and other devices. The solid state nature of SSDs, which uses flash memory instead of moving parts, enables this performance and reliability benefits. Magnetic tapes. Magnetic tape is a reliable and durable storage medium that can hold large amount of data. However, it has a slower access time compared to main memory and hard disk, making it less suitable for the frequent and random access. The primary use of magnetic tapes are for the data updates, storage infrequent used data informations, and transferring data between systems. Tape storage is a cost efficient solution for long term archiving and preserving important data. Logical blocks. Modern hard disk drives are addressed as large one-dimensional arrays of logical blocks. Mapping sector O is the first sector of first track on the outermost cylinder. The mapping process in order through this track, then through the rest of the tracks in the cylinder, and then through the rest of the cylinders through the outermost to innermost, from the outermost to innermost. Challenges: most disks have more defective sectors, but the mapping hides this but by subsisting separate sector for where elsewhere on the disk. The number of sectors per track is not a constant on some devices. Disk storage is a crucial component for computers, allowing them to access and store data. There are two main ways computers can access disk storage: input output ports. These is the most common method for the small systems where disk is directly connected to the computers. Remote host: in the distributed file system, the computer accesses disk storage via a remote host known as network attached storage. Input output ports provide direct connection between the computer and a disk, while the network attached storage allows from shared access for shared access to store across the network. Both approaches have their advantages depending on the specific needs and setups of the computing environment. Host attached storage refers to the storage devices that are directly connected to the computers to a directly connected to the computers or the servers. We will cover a few common host attached storage architecture, IDE or ATA. So this supports a maximum of 2 drives per input output bus. Fiber channel FC has the high speed serial architecture that can operate over optical fiber. FCAL uh, loop that can address up to 126 devices. Network attached system is a specified storage system that can be accessed remotely over the data network. Client access NAS device using remote procedure call interface like NFS for Unix system and CIFS for Windows. Typical NAS implementation is a RAID array with a software that handles the remote access protocol. Advantages is that all the computers on the LAN can easily share a pool of storage just like a local storage. And the disadvantage is that NAS is less effective and has low performance than some direct attached storage options, and the network input output can increase latency. Storage area network SAN are the high speed networks that connect storage devices with servers, typically using enterprises entertainment for mission critical application. SANs provide a dedicated storage network separate for the general purpose network, allowing for the high throughput and low latency for storage traffic, improving application performance. SANs are connected various storage devices like disk arrays, tape libraries, and other storage applications, which can then be accessed by multiple servers, enabling efficient storage resource allocation.
Hello guys, today I am going to discuss about memory management, input-output file system and interprocess communication. First we want to know main memory. Basic hardware structure of main memory. Program must be brought into main memory and placed with the process for it to be run. Then main memory and registers can directly access to CPU to run the program. Then these are the points. Registers access in one CPU clock. Main memory can take many cycles. Cache sits between main memory and CPU registers. Protection of memory required to ensure correct operation. A pair of base and limit registers used to divide the logical address. Next is address binding. Address binding of instruction to memory address can happen at three different stages. First one is compile time. Next one is load time. Then after that all, last step is execution time. First we want to see what is compile time. Compile time means if memory location is already known, then absolute code will be generated. If the memory location from starting it will be changed, then the code is recompiled. Then loading time. Loading time means must generate relocatable code if the memory location is not known at compile time. Execution time. Execution time means binding delayed until runtime if the process can be moved during its execution from one memory segment to another. So it needs a hardware support to run or execute the process. Next is file system. File system provides a mechanism for online storage and access to both the data and programs of OS and all users who are using computer system. Then the file system consists of two distinct parts, collection of files and each storing related data, directly structures which organize and provides information about all files in the system. The file system have six subheadings or subparts: file storage, file hierarchy, metadata management, access control, space management, and file access. First, we can see what is file storage. It stores the data in files. We are giving input. After that, we will get some output. It will be stored in the file storage. Then files are fundamental unit of data storage. Next one is file hierarchy. File system organize files in the directories or folders, allowing users to create hierarchy that structures file logically. Next one is metadata management. The file system tracks metadata such as file names, permission, timestamps, and file size. Access control. We want to enter some inputs in the file. So before that, we want to get permission from the file. Next one is space management. It allocates the spaces on the storage devices for files and ensure efficient use of available space. Then file access. It provides a mechanism for programs to read and write data in files such as opening, closing, reading, and writing to the files. The types of input-output operation in the operating system are input and output. Input means the data or signal which is received by the system from external devices. Example, keyboard inputs, mouse movements, like that. Then output means the data or signal sent from the system to external device. Example, displaying the image, texting on a screen, printing a printer, like that. Next topic is interprocess communication. In certain situation, one process need to communicate with another process. So it is done by three methods: synchronization and signals, message passing, shared memory, object. Second one is message passing. Unix pipes allows a child process to inherit a communication channel from its parent. Data returned to one and can be read from other. The pipes are divided into two types: anonymous pipe and named pipe. Anonymous pipes is used to redirect standard input or output to child process on the same computer. Named pipe is used to transfer the data between process on different computers or between unrelated process. The pipes is the method used to transfer the data between the process. Shared memory allows fast communication with data returned by one process immediately related by other. The disadvantages are no synchronization mechanism. A process cannot query the OS if shared memory has returned to suspend until data is returned. The third and last one is shared memory object. It acts as a backing store for shared memory regions, similar to how files back memory mapped regions. Shared memory mappings resolve page faults by mapping page from a persistent shared memory object. Shared memory objects retain their contents even if no process are mapping them into virtual memory. These are the method in IPC. Then the shared memory is faster and a reliable method in the IPC. The shared memory, also known as multiple process, because at the same time it transfer number of
We are
copies
going
of
to
data.
explaining about the process management and the process scheduling in this video, and we are going to learn about some key concept in this in this lecture, and some challenge we are going to have in this video. Okay. Process management and the process scheduling are the critical for optimizing the system performance and resource utilization in the computer systems. Means resource utilizations in the computer system means the CPU have to utilize the resources with the 100%. Means like it may be like creating, terminating, or execution or scheduling. It may be anything like a resources. A system have to perform with the optimization. Okay. Okay. In this presentation, we will provide an overview of key principles, algorithms, and challenges involved in this critical operating system functions. And we are going to explain in all these terms in this video. First of all, we have to know about what is a process management. Okay. Process management means there are three concepts. Okay. Process lifecycle, resource allocation, and the synchronizations. Process lifecycle means it may be like a managing, creation, and execution and termination. These are the life cycle. Means it will having the life cycle that it may having the managing also, creation also, and the execution also, termination also. Means having the efficient resource allocation and utilization will be there. Okay. And resource allocation, assigning and managing the system resources like CPU, memory, and input output for to the active processes. Active process, the resource will be allocated to work on them. Okay, synchronization means coordinating the access and sharing of resources between the concurrent processes to avoid a conflict. The resources will be shared continuously to the process that it should avoid a conflict. And next, importance of process management. Uh, Importance of process management, improved efficiency means efficiency process management optimizes the resources utilization and the system throughout. Okay, means having the CPU utilization will be the 100%. Okay, so that the efficiency will be the best in the operating systems. Okay, enhance responsiveness means the system have to give means the system have to respond to the user request. What is the user request, what is the prompt the user have given, so that the process scheduling have to ensure that timingly response to the user request and the system events. Okay, and fairnesses and the isolation. Process management ensures fair access to the resources and isolates the processes for each other so that the isolation and the fairnesses will be so grateful in the operating system in the process management. Okay, we are going to explain about some algorithms so that the process scheduling have are going to be easy. Okay, first come, first serve. Okay, FCFS. Okay, processes are executed in the order they arrive simplistic but not always efficiently. Okay, for example, the first person in the line buys a ticket, and then the next person, and so on. Like this, it is an example for first come, first serve. Okay, the shortest job. Now, shortest job. A CPU can uh, the process with the shortest burst time and the arrival shortest burst time executed first improves average wait time. Okay. For example, a CPU process scheduling algorithm and sorts the uh, sorts and executes the process with the smallest execution. The time first and then the subsequently the process with the increasing execution time. Increasing execution time. This is the example for shortest job first. Okay. Round robin. Round robin means processes are executed in a circular queue with a fixed time. So this ensures the fairnesses. Ensure the fairnesses. Okay, having the process are in the circular manner so that fairness and ensuring fairnesses and the fixed time slashes like fixed time slash because as the process are in the circular queue. Okay, next processes next priority scheduling. Processes are scheduled based on their assigned priority. Higher priority processes are executed first. That means which process having the higher priority, it will be executed first. Okay. Next, a primitive and a non-primitive. Primitive and a non-primitive means the OS interpret a running process to execute a higher priority process. Higher priority process provides a better response. For example, for example, time zero. For time zero, the process 4 is the only process in the system and is allocated in the CPU. Okay, allocated in the CPU. And time one. Okay, process 3 process 3 arrives with a higher priority and then the process 4 means process 3 having the higher priority than the process 4 so that the CPU allocation, since the P3 has a higher priority, it permits the P4, it permits P4 and then the and then in and then and is allocated the CPU. A P4 is moved to the ready queue. Means P4 is in the ready queue. So because the P4 is having a low priority than the P3. So P3 has a higher priority, so it will go to the allocation allocated to the CPU. Okay, non-primitive means a running process cannot be interpreted until it voluntarily gives up the CPU in a simpler event, simpler to implement. Okay, next, thank you. And these are the concepts we are gone through the slides. So hopefully you have understood this video. So thank you, have a nice day.